So the title of it is Prisms. So we are looking at just a portion, maybe it's a pretty big group of these solids, okay? But looking at these prisms, how to identify the solid figures, finding the surface area and the volume of prisms, solving practical problems that go along with them. So there they are. Giving you a bunch of definitions there. Let's just quickly go through those. Prism is a solid figure having at least one pair of parallel surfaces that creates a uniform cross section. You know, the definition is all fine and dandy, but I think the examples provide a good explanation of this. One of these is a prism and the other one is not. Which one is the prism?
Triangle. The triangle is a prism.
Trick question's good.
They both are.
Nope. Both of them are solids, but only one is a prism.
The triangle one.
Triangle and prism. Is that a trick question?
That's a cube.
This is a cube, this is a prism. Okay? This is a prism. What is this thing called in its most basic definition?
Dome. Pyramid.
Pyramid. Yep. So pyramid is the pointy ones. Prisms is when you have the opposite faces occurring on both ends of that face. So again, the definition can be kind of wonky. I think the definitions do it a little bit more justice, or sorry, the examples do. But we already talked about faces. We're going to talk more about the bases of a prism. Here's another prism here. This is called a pentagonal prism. And why is it a pentagonal prism as opposed to a hexagonal prism?
Because it has 5 sides?
The base of it has 5 sides. So the point that I want to make is your bases, okay, of a prism, it's got to occur on both ends. So there's base 1 looking at you, and then base 2 is the other end of it. So for a prism, in order to be a prism, the base has to occur on both ends of it. Now we could say that for a cube, bottom, top, those are your 2 bases, but technically you could say the front and the back side of the bases, or the left side and the right side of the bases. But again, the best examples are like this one here, this guy right here. What's the shape of the base?
Rectangle.
Nope.
Triangle.
Triangle. Okay. Why? Because it occurs on both ends. I got the triangle here, and I got the triangle here. We can't say that about the rectangles. We could say rectangle here. Yes, you got a rectangle here, but they're not exactly opposite of one another. They're not parallel to one another. All right? So that's what the base is. It occurs on both ends of a prism. Lateral faces, we'll talk about those in a minute. Sides of the polygons are the edges of the prism, okay, and the corners are referred to as the vertices. The perpendicular distance between the bases is called your altitude or your height. Altitude is the technical name, but height works as well. And lastly, in a right prism, the lateral edges are perpendicular to the base. Okay, we'll kind of think at the end, we kind of look at one where it's not a right prism, but 90–95% of the ones that we look at are right. The Leaning Tower of Pisa, have we heard of that?
Yeah.
Technically, it's no longer a right prism. Okay, well, I don't know. I'd have to look at a closer picture of it and see if they're still horizontal to the base or whatnot. But you get the idea. When it starts to slant. Do you guys remember the old CD stacks? CDs? Take the corner too fast and the CDs start to slide over, so it goes up at an angle. It's an example of a non-right prism. That's now called oblique. So I understand I'm giving you a lot of terms, a lot of information in a short amount of time. Let's just go through some of these together. The components of a prism are the faces and the edges. Let's just go ahead and count all these faces and edges. Go ahead and do it for this one here. Identify the number of faces, number of vertices, and the number of edges. You can go F for faces, V for vertices, E for edges. Number of faces that we have here for this one.
7.
Yeah. So you got 2 bases, front and back, and then you got these 5 faces that go around it. So 7. Zave, were you able to come up with the number of vertices?
10.
Yeah. 1, 2, 3, 4, 5 points on the first base, and then another 5 on the back base. So very good. 10. Number of edges.
15.
Did anybody get it something other than 15? 6? 8?
Shoot.
It was 15. There was your trick question. This one over here. How many faces? Yeah. You know, a rectangle or a square still have those 4 sides. So you got 2 bases plus those 4 sides. 2 plus 4 is going to get you 6 faces. Vertices.
8.
Yeah. Edges. 4 on the front.
8.
4 on the back. 4 more to connect those. So I don't think it's 16, but
That's 12.
it is. There we go. Take your time as you count those. You guys know what they are. Just count them and you're good. So we've kind of talked about these already. Again, I guess the biggest thing that I want to make sure that we're good on is prism, right? This is a prism, not a prism anymore. And the biggest takeaway from this is, or the biggest thing we need to know, is that prism will have 2 bases. So if you want to star it, 2 bases. When we get into the pyramid later on in the week, now we go down to 1 base. But we could have a rectangular prism, triangular prism, trapezoidal prism. Basically, we can have every polygon that we had before, and that can be a prism. We could have an octagonal prism if we wanted to. You know, the octagon, MMA fighting, technically the way the cage is around it, it's actually not just an octagon, but it's an octagonal prism, just without the top of it, and so forth. With all of this, with our prisms, today's focus is going to be on volume. So we're just focused on volume. Volume. What does volume represent? How so?
Inside. The space inside.
I like that term. The space that's enclosed by the solid or the prism. Absolutely. If we were to fill it up with water, how much water can we put into it? Sand, whatever material you want to choose. It's how much can go into it. Fish tank, how much water can go into that thing. All right. Volume of a right prism. We're going to start off with the most basic definition we can have, or I am anyways. Volume is equal to big A times H. And I actually always like to call it big B. What does A represent? Of what?
The base.
Yes. Where A is area of the base. Some of you could argue it's length times width times height. Well, if it's a rectangular prism, yeah, you're right. Okay, you can find the volume by taking length times width times height. Let's see if I can make this. There it is. Rectangular prism. Length times width times height. Could I also use this formula here?
Sure.
And why does it work out that way? Well, what's your base?
You're just adding everything up at the end, basically.
Basically, because your area of the base is this length times width, right? So length times width is equivalent to the area of the base. So that's why both of those work for a rectangular prism. And that's where the idea comes from. That's why the two go hand in hand. Volume of a cube. This one's kind of a special one that we can have. It's still length times width times height. You could say that. But if we were to look at a cube, what would be true about the length, the width, and height? All three dimensions would be the same. So side times side times side, which is just s cubed. So if we wanted to, sorry, I wrote squared, but it needs to be s cubed. Make sure you make note of that. S cubed, not squared. My bad. S cubed for that reasoning, where s is the side length of each cube. Good on those formulas? I'll do the first couple with you. Can you find the volume of that guy? Yeah, 9 is your length, 5 is your width, 3 is your height. 45 times 3, 135. Inches what? Probably need to talk about that. Cubed. We should probably talk about that, why it's also that. 9 inches, 5 inches, 3 inches, inch, 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 3 of those inches. Before, when we did polygons, it was just like 9 times 5, so inch times inch was your inches squared. So there's the algebra behind it. Let's do another one here. Volume of this guy. Actually, you know what? Let's do this one down here, and then we'll come back to that.
Times edge divided by 2.
Okay, which one are you talking about?
Triangle.
Let's go ahead and do that one. Why not? What did you say?
Isn't it like base times the height divided by 2 and the edge or whatever?
Yeah. Volume is going to be equal to the area of our base times height. This is where it gets tricky. Pay close attention. What is the height of the prism? Do we know it?
Oh, it's 6 meters.
Remember this from last year?
No.
No? Well, you got it right. This is the height of your prism. And the height is not always the vertical distance. Okay? Here it is. Triangular prism. If I set it on the table like that, one would think the height is gonna be that vertical distance of the prism right there. Does everybody see this? Your height of the prism is not this. The height of your prism is actually the distance from that point to that point there. Everybody see that?
Yeah.
It's the distance from base 1 to base 2. Okay? Because you can orientate this thing however you want to. It's not always the vertical distance when it comes to a prism. So this is the height of the prism right here. Once again, the problem is we need to find the area of this base. All right. So we need to find A, kind of some scratch work off to the side. Just so we're all clear. The face of the base is this one right here. The shape of that base is a triangle. And that's going to be my A value right there. I'm going to give you one dimension that was not given to you in the diagram, and that's going to be that one there. 3.7. I'll make your life a little bit easier. Now that we have that 3.7, now can we find the area of the base? No.
33,
No, you said 3.7 on the height?
Yeah, 3.7 is your height.
5.55.
33.3.
It's just 33, gets the rounding, that's the number.
I'm going to go with 5.5 for the area of the base. That is the area of that shaded region. And once again, I can't emphasize this enough. Why did I go base times height divided by 2? Because the base is in the shape of a triangle. Absolutely. So are you going to use base times height divided by 2 for every time that you find A today?
No.
No. You got to select the correct formula that matches the shape of the base. Does that make sense? Identify what shape of the base is, and then use that particular formula to find the area of that base. Alrighty? But now I can plug that in for A. 5.5 times 6, you're right, 33.3. Looks like we're in meters. Last one down below. Looks like we are looking at our cube. Side length is 5 for all 3 sides. 5 cubed. Anybody off the top of their head? 5 cubed?
125.
There you go.
Good, good.
Just about done. Oh, 2 good ones here to close it out. I'll do these with you. First question I'm going to ask you on your own. Take a minute and see if you can identify the shape of the base. Is it a triangle? Is it a rectangle? Is it a circle? Is it a pentagon? I hear rectangle. I hear trapezoid. Do I got another one? Austin, which one are you going to go with? Trapezoid. And yes, it is a trapezoid.
Oh.
There's our base right there. It is a trapezoid. Volume is equal to the area of the base times the height. Area, if we want to do that off to the side, you said it was a trapezoid, right?
Yeah.
So we have to use that area formula. 1/2 base 1 plus base 2 times the height. Base 1 being 8, base 2 being 6. And what's the height here? Ooh, I gotta be careful on how I ask this. The height of the base, that is.
That would be 5.
It is 5. So that's our big A. What's the height of the prism now?
20.
Yes. You guys seem to be catching on to that. 35 times 20. Well, 35 times 2, 70. Add on another 0, 700. Anybody do that in their head? It's okay. Oh, baby. Here we go. Gave you a good one to finish things out on. No. Answer is 700. Gave you a good one to end things on. Find the volume of the vase. Can you sketch the face that's going to be your base? Like, as we look at this thing, there's got to be, this is a prism, all right? So because it's a prism, we got to have 2 bases here. And the front-facing base is obviously the one we want to try to identify. Any thoughts?
Yeah, I don't like it.
Don't like it. It's okay. It's understandable. What I would tell you to do in your notes is take your pencil, or if you got some colors, that's fine. But I would shade or color in this right here. Because that guy right there is your base. And to me, it looks like we got what? A trapezoid here on the bottom half. And then a rectangle on the top half. Is that right? Okay. So when we go to find area, I'm going to redraw this. This is maybe a better looking view of it. Almost looks like it's a guitar or something. But yeah, this is a compound figure right here. Trapezoid combined with a rectangle. So we need to first find the area of the trapezoid, but also find the area of that tall, skinny rectangle. Everybody okay with that? If I can find this area and I can find that area, I combine those 2 together, and that'll give me the area of the entire yellow figure. Go ahead and see if you can find the area of the trapezoid, see if you can find the area of the tall, skinny rectangle, and get your total A value. Let me let you work on that. Total A value. area of the trapezoid. You guys agree? 1/2. Base 1 is 8. Base 2 is what? Yeah, this one dimension up here carries down right here. So that is 1 right there. And the height of this thing, yep. 1/2 of 6 is 3. 9 times 3, 27. You're right. Rectangle, length times width, 10 by 1. So that's 10. If I add those two amounts together, total area of the shaded is 37. Lastly, what's the height of the prism? 2.